Good morning, children. Today we are going to learn about coplanar lines. What do you mean by the word coplanar? Suppose you have a plane like this, lines that are in the same plane. They may be parallel or perpendicular or intersecting. So two lines are on the same plane. I call them as coplanar lines. What is the condition? From the first line, identify the point and direction. This represents point. S into what? Represents direction. Similarly, the second line, without T is point and with T I will say direction. So we can say point as A vector, direction as B vector. Point as C vector, direction as D vector. From this, let us write down what is x1, y1, z1. The point, it is 5, 7, -3. And direction we can call B1, B2, B3. What is B1, B2, B3? 4, 4, -5. From the second line, I am writing the point x2, y2, z2. Generally remember, points we take x, y, z. First point means x1, y1, z1. Second point implies x2, y2, z2. And if there is a third point, x3, y3, z3. Directions we take b1, b2, b3, c1, c2, c3 or d1, d2, d3 like that. So here the point is 8, 4, 5. The direction we have taken D, so D1, D2, D3 equals to 7, 1, 3. What all I know? X1, y1, z1, x2, y2, z2 and the two directions. What is the condition? Coplanar lines. The word coplanar lines imply the determinant x2 minus x1, y2 minus y1, z2 minus z1. This is again difference of the points. This direction and this direction. B1, B2, B3, D1, D2, D3 should be equal to 0. Substituting in the formula, we get x2 minus x1, 8 minus 5. We'll find out here. x2 minus x1 is equal to 8 minus 5, that is 3. y2 minus y1 equals 4 minus 7, that is minus 3. z2 minus z1 equals 5 plus 3, and that is 8. 8 minus 5, 4 minus 7, 5 minus of minus 3 is plus 3. Let us substitute these values here. 3 minus 3, 8. B1, B2, B3 from here 4, 4 minus 5. D1, D2, D3 7, 1, 3. Just expand the determinant, check whether you get 0. If the answer is 0, it is coplanar. Hide the row and column. 12 plus 5. Minus of minus 3 is plus 3. Hide the row and column. 12 plus 35. 8 into hide the row and column. 4 minus 28. Simplify and check whether you get 0. As I simplify, I get 0. So I can declare the lines are coplanar. Now the question is to write the vector equation. Vector equation of the plane. How to write the formula? It is through 2 points and 2 directions. Any one combination is enough for me. 1 point, 2 directions let me take. R vector equals A vector plus S into B vector plus T into the direction is D vector. Let me remember, direction is B vector, direction is D vector. So A plus SB plus TD. What is B vector? From here, B vector is 4i, 4j minus 5k. And what is D vector? The next direction 7I plus j plus 3k. Since we are marked in the question directions as B and D, let me give the name directions. Point. What is the point we have taken? A vector, that is 5I plus 7j minus 3k. Substituting this A, B, D in my equation, R vector equals A is 5I plus 7j minus 3k plus S into B vector is 4I plus 4j minus 5k plus T into D vector is 7I plus j plus 3k. And that is the answer. Question number 2. Show that the lines are coplanar and find the Cartesian equation of the plane. As I read the line equation, numerator gives me the point by changing the symbol. So what is x1, y1, z1? Minus 2 will give me 2, minus 3 implies 3, minus 4 implies 4. From here, we can also write what is A vector. 2I plus 3j plus 4k. And the denominator gives me the direction. So this I call point. Denominator is nothing but direction B1, B2, B3. 1, 1, 3. From which I can write what is B vector? I plus j plus 3k. Similarly, from the second line, the point is given by the numerator, say x2, y2, z2. Change the symbol and say 1, 4, 5. Direction, we can call denominator D vector, D1, D2, D3, which is nothing but minus 3, 2, 1. From here, I can write what is C vector, that is I plus 4j plus 5k. And what is D vector? Minus 3I plus 2j plus k. As we have written it all, what is the question? Coplanar. So we say coplanar lines imply determinant x2 minus x1, y2 minus y1, z2 minus z1, b1, b2, b3, d1, d2, d3. First line, difference of the points, direction equals to 0. Let me simplify the answer. x2 minus x1 we can also find out. x2 minus x1, 1 minus 2 minus 1. y2 minus y1, 4 minus 3, 1. z2 minus z1, 5 minus 4. That is also 1. So substitute minus 1, 1, 1. b1, b2, b3 is 1, 1, 3. d1, d2, d3 minus 3, 2, 1. Check whether you get 0. We all know to expand row and column, hide it, find out the answer. To write Cartesian equation, we have the formula determinant. The same thing I will write instead of the 2 point subtraction. We write x minus x1, y minus y1, z minus z1, b1, b2, b3, c1, c2, c3 equals to 0. Substituting in this, we get x minus 2, 3, 4. X minus 2, y minus 3, z minus 4. b1, b2, b3, the same from here, 1, 1, 3, minus 3, 2, 1 equals to 0. Expand the determinant, the symbols plus, minus, plus. X minus 2 into 1 minus 6 minus y minus 3 into 1 plus 9 plus z minus 4 into 2 plus 3 equals to 0. Expand it, find out the answer. As we simplify, we get minus 5x minus 10y plus 5z 40 minus 20 plus 20 equal to 0. Divide by minus 5, we get x plus 2y minus z minus 4 equals to 0, and that is the Cartesian equation. Question number 3. If the straight lines are coplanar, find the distinct real values of m. As I read the straight line, the numerator change the symbol and write x1, y1, z1. 1, 2, 3. And the denominator, the direction, b1, b2, b3. We write 1, 2, m square. Similarly, from here, the numerator tells me the point x2, y2, z2, 3, 2, 1. The denominator gives me the direction d1, d2, d3, and that is 1 m square, 2. As I have written all this, what is the condition for coplanar? Coplanar lines implies determinant x2 minus x1, y2 minus y1, z2 minus z1. b1, b2, b3, d1, d2, d3 should be equal to 0. See the condition, difference of the points, the direction equals to 0. And we know, find out x2 minus x1, 3 minus 1, that is 2. y2 minus y1, 2 minus 2, that is 0. z2 minus z1, 1 minus 3, that is minus 2. So we get 2, 0, minus 2. b1, b2, b3, 1, 2, m square. d1, d2, d3, 1, m square, 2 equal to 0. Expand the determinant. How do you expand? Plus, minus, plus. 2 into, hide the row and column, 4 minus m square into m square is m power 4. When you multiply, add the powers. 0 into anything 0, forget it. Minus 2 into, hide the row and column, m square minus 2 equals to 0. Simplifying this, 8 minus 2m power 4 minus 2m square plus 4 equal to 0. Simplifying, minus 2m power 4 minus 2m square, 8 plus 4 is 12, that is equal to 0. As I simplify, dividing by minus 2, m power 4 plus m square minus 6 equal to 0. Let me simplify the problem by factorizing. M square the whole square plus m square minus 6 equal to 0. What are the two factors that I get? Minus 6, I want 1. 3 into 2. This is plus. So plus is the bigger number, minus is the smaller number. My equation is with m square. So I write m square plus 3 into m square minus 2 equal to 0. Or m square equal to minus 3, m square equal to 2. M is equal to root of minus 3, m is equal to root of 2. And we know whenever negative number comes, it is I. Square root comes plus or minus. Root 3, we don't know the value, write as it is. Similarly here, whenever I take square root, put plus or minus root 2. Now my question is distinct real values of m. So what are the distinct real values of m? I need to write only this. So we take and write distinct. Distinct implies different. Real values of m equal to plus or minus root 2, and that is the answer. Question number 4. If the straight lines are coplanar, find the value of lambda and Cartesian equation of the plane containing the lines. Same as the previous problem, but extra condition, we need to find the equation of the plane containing the lines. This is the plane, there are two lines. So I have the point and direction, the point and direction. So 2 points and 2 directions are there. We take any 3 and find the Cartesian equation. So let us proceed. The numerator tells me the point. x1, y1, z1 equals to, changing the symbol, 1, minus 1, 0. Denominator is the direction. b1, b2, b3 equals 2, lambda 2. So remember, numerator is point, denominator is direction. Same idea, the second line, point, x2, y2, z2. Changing the symbol, minus 1, 0. No number here, treat it as 0. Direction tells the denominator, that is d1, d2, d3 equals 5, 2, lambda. So this is A vector, B vector, C vector, D vector. B vector, we have taken b1, b2, b3. D vector, we have taken d1, d2, d3. Having known all this, coplanar lines, what is the condition? The lines are coplanar. Coplanar means they lie on the same plane. Implies determinant x2 minus x1, y2 minus y1, z2 minus z1, b1, b2, b3, d1, d2, d3 equal to 0. Substituting x2 minus x1. Find out the answer. Minus 1, minus 1. It is minus 2. y2 minus y1. Minus 1 plus 1. It is 0. z2 minus z1. 0 minus 0. That is also 0. Minus 2, 0, 0. b1, b2, b3 is 2, lambda 2. And 5, 2, lambda equals to 0. They have given they are coplanar. Maintain equal to 0 in every line. Find out what is lambda. Expanding this, minus 2 into, hide the row and column, lambda square minus 4. Lambda into lambda, lambda square, 2 2s are 4, equals to 0. So 2 also cancels. I can simplify. Lambda square minus 4, 0, or lambda square is 4, or lambda equal to plus or minus 2. So we have found out what is lambda value. My next step is to go with Cartesian equation of the plane. What is the formula for Cartesian equation? Determinant. The same thing I will copy, but now I will write x minus x1, y minus y1, z minus z1. b1, b2, b3, d1, d2, d3 equal to 0. Substituting x minus, what is x1, y1, z1? 1 minus of minus 1, z minus 0. b1, b2, b3, 2. Lambda value, any one thing let me put plus 2. 2, 2, 2. 5, 2, lambda value we are putting 2 equals to 0. Expand and find out the answer. As we expand, minus 6 is common, which I can divide and change the symbol throughout. Y minus z plus 1 equals to 0. So we have arrived at equation of the plane when lambda equals to 2. Now, wherever lambda comes, let me put minus 2 and simplify the answer. Putting lambda equals to minus 2, we expand x minus 1 into, hide the row and column, 4 minus 4 minus y plus 1 into, hide the row and column, minus 4 minus 10 plus z into, hide the row and column, it is 4 plus 10 equal to 0. Simplifying the answer, 4 minus 4, 0 into anything, 0. Take this minus sign inside, minus y minus 1 into, minus 4 minus 10 is minus 14, 4 plus 10 is plus 14 into z equal to 0. Dividing, or you can multiply 14y plus 14 plus 14z equal to 0. Dividing by 14, we get the answer y plus z plus 1 equal to 0. So we have achieved the two equations, one with lambda as minus plus 2 and the other with lambda as minus 2, and the equations are different. Notice, here it is y minus z plus 1 0, here it is y plus z plus 1 is 0, and that is the answer.